Good afternoon, Miss Ray. My name is Lance, and together with my group members, Hong Seng, Gordon, and Daniel, we will be presenting about water tracking in a factory and how we are going to achieve it. So, how will we test for it? In this project, we have included the workings, HDL code, block diagrams, simulation waveforms, as well as this video to help explain the process. To explain how the water tracking works, there will be a sensor that will be used to detect the number of bottles on the conveyor belt. We have designed a system whereby whenever the limit is reached, an LED will turn on and the counter will stop counting. Now I will pass the time to Daniel for him to explain the workings.
As you can see, the workings have been put together in a table form. Depending on the input of the tip switch, the limit of the counter can be set by the user as they see fit. As an example, if the user wants to count up to 25 on a particular day, they can input the binary number 11001 into the tip switch and it will not go up any further. The user will then be able to input a specific number that they want to count up to for that day, and when the counter counts up to that specific number, the LED will turn on and not count up anymore. This will continue until the reset button of the tip switch is pressed and the 2 7-segment display will change to 0. When the sensor is off, the number will not change as seen in the working.
As for the HDL code, we have prepared 3 different codes named Counter Up, 7-segment 1, 7-segment 2. In Counter Up, this code was written with the purpose of counting the number of bottles and to set the limit. At the input, we have the clock to count the number of objects, a reset to reset the system, a sensor to detect the objects, D4, D3, D2, D1, D0 to set a limit to how much objects that we will be counting, an LED to indicate that we reached the limit, and an output Q to the 7-segment displays to display the numbers. As you can see, when the reset is triggered, the LED would be turned off and the signal will become 0. And also, when the sensor is triggered off, it will not be able to count, and therefore the numbers will stay the same as seen in the working. Also, for this line, when the count sig equals to the input signal, it will not count up any higher and the LED will turn on. In 7-segment 1, its purpose is to program the LED display in the 1's position, which will be the code on the left here. As for the code on the right, it's the program for 7-segment 2. Its purpose is to program the LED display in the 10th position. In short, the main program Counter Up is to count the number of objects, and the 7-segment displays are to display the number of objects that have been counted.
For the block diagram shows different programs as blocks, so as well as show how they are interlinked using the inputs and outputs. Even though it is not in the report, the pin planner plays a very important role in this project, as the pin planner is the one that assigns where the different pins will go. And for the simulation waveform, as you can see here, the program runs as per normal until an anomaly appears, such as the sensor not sensing any bottles or the reset button is pressed. As you can see, at 30 nanoseconds over here, the reset button is activated. Therefore, the 2 7 segment resets to 0. Another anomaly occurs at 110 nanoseconds as well when the sensor is not sensing. The counter stops at the number without changing.
Okay, so on behalf of my group, I'd like to thank you for watching this video. We hope that it was informative. That's all, folks.